Welcome to the deep dive. Today we're jumping into something pretty spectacular. The Carrington event of 1859.
Right, this absolutely massive solar storm.
Yeah, it knocked out telegraphs globally, lit up skies with auroras way down south, places like the Caribbean, apparently.
Unbelievable places, yeah.
So our mission today is to kind of unpack this event, what happened, what it meant back then, and maybe more importantly, why we should still be thinking about it today.
Absolutely, because it's not just history. We've got historical accounts, sure, but also modern analysis looking back. It really shows us the sun's power and, how our tech can be vulnerable.
Okay, so set the scene for us. Where does this story, this electrifying story, really begin?
It starts September 1st, 1859. You've got Richard Carrington, an English astronomer.
Okay.
He's doing his thing, observing the sun, which, people did, and he sees this incredibly bright flash, just bam, white light.
And that was unusual.
It was the first time anyone had scientifically observed and actually, recorded a solar flare, the very first one.
Wow. So that was the flare, the opening act.
Exactly. That was the warning shot, you could say. Then, about 17, maybe 18 hours later, the main event arrives.
Which was?
A huge coronal mass ejection, a CME. Think of it like the sun just ejecting this giant cloud of magnetized particles out into space.
Right, a solar burp, basically.
Yeah, sort of, yeah. But usually these CMEs drift towards Earth, taking maybe 2-3 days. This one,
Faster.
much faster, under 18 hours. That tells you he was moving exceptionally fast, packing a serious punch. A real cosmic fastball, like you said earlier.
Okay, so the solar tsunami hits Earth, mid-19th century. What actually happened on the ground?
Well, the big tech of the day was the telegraph system.
Mm.
And it got absolutely hammered.
Hammered how?
Across Europe, North America, systems just went down kaput. Operators were reporting getting actual electric shocks from their equipment.
No way. Shocks.
Yeah, and sparks flying off the telegraph pylons. Really dramatic stuff.
That's incredible. And isn't there that story about telegraphs working even when they weren't plugged in?
That's the really wild part, yes. The geomagnetic storm, the disturbance in Earth's magnetic field caused by this CME hitting us, it induced these incredibly powerful electrical currents.
In the ground.
In the ground, and crucially in the long telegraph wires themselves. Strong enough in some cases that operators could disconnect their batteries and keep sending messages just using this, naturally generated power.
Just running on solar storm juice? That's bizarre.
Truly bizarre. A fascinating consequence.
Then skies. The auroras went nuts, right? Not just the usual northern lights.
Oh, completely unprecedented. Auroras were seen at latitudes nobody thought possible, down to Cuba, the Caribbean, even Hawaii.
Hawaii. That's
Yeah.
mind-blowing.
Imagine seeing the sky shimmering like that over a tropical beach. And they were bright, so bright. People reported being able to read newspapers outside at night just by the auroral light.
Wow. So, okay, it wasn't just weird tech glitches and a light show. This actually changed science.
Oh, absolutely. The Carrington event was the smoking gun. It undeniably linked activity on the sun directly to effects here on Earth, specifically these geomagnetic disturbances. It basically founded the field of space weather research.
Right. It forced people to look up and connect the dots.
Exactly. Understanding that solar-terrestrial connection became a real thing.
Okay, let's fast forward. Our world today, we're plugged into everything, everywhere. What would a Carrington-level storm do now?
Well, the potential impact is frankly terrifying. We rely so heavily on satellites, GPS,
Everything from banking to farming uses it.
everything. Navigation, communication, timing for financial networks. A major storm could cause widespread, long-lasting failures. Think about cascades if those systems go dark.
And the power grids, that seems like the really big one.
That's probably the scariest direct impact. A direct hit could induce currents that overload transformers, causing massive blackouts. Not just for hours, but potentially weeks or even months across entire continents.
Months, the knock-on effects.
Hospitals, water supply, food distribution, communications, everything grinds to a halt. Plus, huge risks for air travel, astronauts in space, the economic damage. Estimates run into the trillions of dollars.
Trillions. That's hard to even comprehend. Is this a once in a million years type thing? Or is it something we should genuinely worry about?
Well, that's the slightly unnerving part. We used to think maybe once in a century or even less frequent. But recent studies suggest these superstorms might happen more often.
More often.
Potentially, yes. And we actually had a very near miss back in July 2012.
I remember hearing something about that.
Yes, CME, potentially as strong as Carrington's, erupted, but it just missed Earth's orbit. It flew through where we had been about a week earlier. a cosmic bullet dodged.
Wow, okay, that's sobering. So are we doing anything? Are we prepared?
There's definitely growing awareness and action. Agencies like NASA, NOAA in the US, ESA in Europe, they constantly monitor the sun.
Watching for flares and CMEs.
Exactly. There are efforts underway to harden power grids, make them more resilient to these induced currents, improving satellite shielding. Developing better, faster early warning systems is key too. Give us some time to react.
Like power down sensitive equipment.
Right, take protective measures. And there's more focus now on contingency planning. What do we actually do if the worst happens?
So the Carrington event, it's more than just a cool historical anecdote. It's a serious warning.
It's a vital lesson, a benchmark. In our world, so completely interwoven with technology, understanding and preparing for space weather isn't, optional. It's fundamental for resilience.
It really makes you think, doesn't it? We build all this amazing tech, this digital infrastructure, but something like the Carrington event shows how vulnerable we still are to just raw natural power from space. What's that balance mean for us long term? Our progress versus our exposure? Definitely something to chew on. Thanks for walking us through that.
My pleasure. It's a crucial topic.